Lesson 10.6, Growth and Decay. We'll just jump right in. Exponential growth is represented by the formula y equals c, parentheses 1 plus r to the t. What are the components of this formula? Well, c is the original amount. And the only tricky thing here is that's at times 0. That can cause some problems for people, so keep your eyes open. R is the rate as a decimal. So if they say something like 4%, you use 0.04. And then T is the time. Usually in years, but it depends. If they say something doubles every day, then they're talking about days, stuff like that. So let's do an example. In 1971, actually I'll rewrite the formula so we can see it. In 1971, there were 294,105 females participating in high school sports, which is an incredibly low number when you think about it. That number has increased by 8.5% every year. So just write an equation for how many females participated since 1971. So we go with the original amount, 294,105. Times 1 plus 0.085 to the t. T being how many years. So we're ready to roll. Can put this together if we want, call it 1.085, but it doesn't really matter. So now we need to know how many years it's been. Well, 2001 minus 1971 is 30 years. So we just put that directly into the formula. That'll tell us how many athletes there are in the year 2001. And punching it in the calculator, I get 3,400,000. So which is scary numbers. Back in 1971, there was a little bit less than 300,000 female athletes, and now there's over 3.4 million today. Probably more like 3.7 today, because that's 11 years ago. That's exponential growth. Things go up very quickly. It's kind of amazing stuff. Another example of exponential growth is when you put money in the bank. If you were able to put a ton of money in the bank and not touch it forever, it just keeps growing and growing very rapidly. Now the problem is it just got a little more complicated on the formula. So again, A is the amount. That's the original amount. R is the original interest rate. T is the time in years. And N is called the compounding time. What that means is if we just had a simple 10% interest rate and it's for 1 year, and we take the money out 2 days before 1 year is up, we actually wouldn't earn any interest because they haven't checked to calculate interest. They're doing that every year. Well, the number of times compounded means when do they check? Typically in a bank, since you get monthly statements, it's every month. So we'll call that compounding. So give some examples. 1 year, N equals 1. Monthly, N equals 12. And you see it's in both parts of the formula, up here and down here. So what's that saying is take your interest rate, which is a yearly rate, divided by the number of months. But don't forget to multiply by years times the number of months, because you're going to do it every month. So it looks a little complicated. It's actually not that bad. So down here we get 24 bucks that we had Native Americans receive for the purchase of the island of Manhattan in 1626. And it's going to be semi-annually, so n is going to equal 2, meaning they check it every 6 months. Interest rate, relatively conservative 6, probably should be a little less than that, but that's okay. And 2 times t equals 2012 minus 1626 equals 386 years. Long time. Put all this in the calculator. And we get a big number. Really, really big number. 1.95 times 10 to the 11th dollars. That's something like $195 billion. Or could it even be trillion? No, $195 billion. So, it's a good deal. That shows you the power of exponential growth. Now, we also have exponential decay. What do you think the formula might be? I'll give you a hint. Looks a lot the same. Except where we used to have a plus, now we have a minus. That's it. So again, original amount, rate, time. Usually in years, but not always. So this is for things that are consistently dropping. For instance, the next problem talks about coal in America, which we've gotten away from. It's relatively dirty to burn, even though we have a lot of it. And the usage has been dropping each year. So as more and more people get better ways to burn things, they get rid of more and more coal. This is our original amount, 114.6. It's been dropping by 0.066. And how much do we use today? So we have to do the whole subtraction, and we get 62. So be careful when you put this in your calculator. You might want to use parentheses. And if we crank it out, we get 1.66 million tons per year. I'd be very curious if that is accurate. I know that we've actually been using a bit more lately, but at the same time, natural gas is becoming very popular. So that is exponential decay. Things drop off rapidly, but they don't completely vanish. When you purchase a car, it drops pretty rapidly because as you drive the car and use it, the value drops. So the first, you tell me you can buy a car that's 1-year-old or 2-year-old, that's a big difference. But if you tell me to buy a car that's 8-year-old or 9-year-old, it doesn't really matter as much. Once it gets that old, it's got very little value. It doesn't matter. So here we go again. Original amount. Losing 10% per year, and it's 7 years. And I made a mistake on my calculator. Try it again. There we go. That car would be worth $14,000 now. So it's lost more than half its value. I think cars actually lose value a little bit faster than that, but it depends. Depends on what you do to the car, depends on a lot of things. That's it for exponential growth and decay. To get you started, try some problems. Good luck.